Hey everybody, this is Matt with MathMath.com. Thanks for joining us here today as we check out the slope of a line. And what is it? What's the slope of a line? That's what we'll be talking about today. We're in the Common Core standard of ratios and proportions, and we're going to analyze and use proportions to solve real-world problems today. All right, our guiding question that we're going to be answering is how can we compare different rates in a graph? Looking at slopes and comparison of different rates, how do they measure up to each other? All right. Now this is a picture of my kids and I as we make sledding hills. And if you think about a sledding hill or a ski resort, or why do they call it a slope? Why on earth would you be coming down a slope? Well, what kind of slope do you see here in this picture? Is it maybe a positive slope or a negative slope? Any idea? Is it going up or is it going down? From the kids' perspective, they're going down, huh? So it's probably a negative slope, but it's going down. If you think about it, the sledding hill, the slopes that you see when you're going skiing or snowboarding, those are slopes, and they can be described using math. Again, there's math and everything. And so what we're going to talk about today is how do we describe a slope of a line or a particular hill or slope or something like that, okay? Let's do it. There's my 4 kids and I as we take a snow day and we get to sled down this hill. Pretty cool, huh? All right, well, let's do it. First, when we talk about fractions and slopes and things like that, we do need to work with slopes or fractions. And how does it work out? Let's look at something like this. You've got 3 random fractions, a over b, c over d, e over f. And do we know what the letters mean? No, we don't, all right? But let's talk about maybe how to put them together. How do you take an a over b and multiply it by c over d and an e over f? Well, remember how multiplying fractions work? It's one of the simplest concepts in math is you just multiply across. So it's a times c times e, and then the bottom would be b times d times f. So your answer, after you multiply across a times c, b times d, c times e, and d times f, gets this. It's just ace over bdoof. You get ACE on top and BDF on bottom. And remember, when you put these letters together, there's an invisible multiplication in between the variables there. All right, so that's what you're going to do. Now let's look at something a little bit harder. When we have A over E, C over B, and E over C, what do you do there? Well, we're going to multiply across, but we can cancel out the same things that are on top that are on bottom. All right, so think about it. What do you have on top that's also on bottom? A numerator. What I mean by numerator, top, bottom, denominator. So what do we have? We have an E on top, so that cancels with E on bottom, because what is E over E? Well, that's 1, so they go away, right? Same thing with the C's here. You've got a C on top and a C on bottom, so C over C, well, that's 1. So we're left with A times 1 times 1, and 1 times B times 1. So you're left with A over B. And simply put, that's how it is. You just cancel them out like that, okay? A over B. Pretty easy, huh? Well, as we look at fractions and slopes, you might see a lot of that, okay? So let's talk about the slope of a line right now. Slopes. This is what you need to know. This is what you'll be responsible for. Slope. Slope is just a number that represents the steepness of a line, and that's it. It's a number that represents how steep a line is. So let's look at it. We'll say it's the rise, the change in y, over the run. Okay, so how much does this line go up or down versus how much this line runs? Think about it. You got to get up when you're getting chased by a bear, and then run. All right, you get up and then run. So it's the rise, the change of y over the change of x. So let's talk about it. When we do that, to find a slope of a line, we have to pick a nice point on the line in the graph, right where they intersect. So like right here is a really nice point on the line. Right there's a really nice point on the line. There would be one right there probably. There's another one right there. And you want to pick 2 of them. Okay? So you want to pick 2 nice points. So let's stick with that first one. And we want to go from this point to that nice point up there. And how much do you rise? You go up 1 space, 2 spaces, and 3 spaces. You don't count the lines because this is 0. You count the blocks. So this would be 1, 2, 3. It goes up 3. And then you got to figure out how much does it go over to the right. So it goes over 1 and 2. So it's 3 over 2. Up 3, rise 2, run. Or up 3, rise 2. So it's 3 over 2 or 1.5. So the slope of this line is up 3 over 2. If you think about it, it could be that you're going up 3 feet, every 2 seconds or something like that. Start here, you travel 2 seconds. Well, how far do you go after 2 seconds? You travel 3 feet, something like that, okay? So this slope is a 1.5 or a 3 over 2, and that's it. If you think about it, slopes are steeper, greater, faster, longer, bigger, and slopes that are shallower, the line isn't as steep, are slower, smaller, lower, and shorter, okay? So let's talk about these slopes of these lines here. We've got a line right here. Remember, you want to pick 2 points. Just pick, say, hey, oh wait, it meets right there, and it meets right there, and it meets right there. But you want to pick just 2 of them. Think about how much does it go up versus how much does it go over. Rise over run. You got an idea? Well, here it's going to go up 2 points to the next dot. It's going to go up 2 and then over 1 space. So my slope here I just write as 2 over 1 or just 2. So the slope of this line is 2. It's a comparison. Remember, we're talking about rates and ratios. It's a comparison of the y versus the x. Let's do this guy. Pick 2 nice points and see if you can figure out the slope of this line. All right, let's start with this point right here. So we're going to go from that point to that point up there. And from those 2 different points, it rises 3 and it runs 2. So my slope is 3 over 2 or 1.5. All right, do this one. Again, you got to pick the nice 2 points. You got to find out where that line intersects the little blue lines on the graph. There's one, and there's one up there. So let's start from this guy down here. It goes up 3, and then it goes over 4. So my slope is 3/4 or 0.75. It's less than 1. Up 3 over 4. Getting the hang of it? No matter which 2 points you pick on the graph, if you think about it here, if I would have picked this point and gone to that point, I would have gotten 6 over 8, which reduces to 3/4 or 0.75, okay? So if you pick 2 points, like this one and that one up there, it would still work no matter what 2 points you pick. You pick this one and that one, you're still going to get the same thing. You might just have to simplify the fraction. All right. Why don't you find the slopes of these lines on your own? Remember, you want to pick 2 nice points. You can go from that guy to that guy. And another nice point. So that point to that point if you want. And then if you think about it, how fast sound travels through water, if you look at this graph right here, it's going to go up 1, 2, 3. That's a nice point right there. There's another nice one right there. If you think about it, how fast does it travel for 2 seconds? Well, 2 seconds is where it hits. You put that in a fraction, and it'll tell you how fast it'll go per second. So the slope of a line can tell you how fast an object is moving, or something like sound. Pretty cool, huh? All right, how'd you do? You ready? Here they are. Here it is. 2 over 5, 3 over 4, and then 3 over 2, or 1.5 kilometers per second. So if you think about it with sound traveling through water, it's 3 kilometers per 2 seconds, or 1.5, 1.5 per 1 second. The slope becomes the unit rate. Remember that from previous lessons. All right. Well, can you answer this question now, how we can compare different rates in a graph looking at the slopes of a line? And that's pretty much it for today. We talked about the slope of a line and sledding and snow and pretty cool stuff. Well, this is Matt with mathsmath.com. Thanks for joining us. Check us out on Facebook at Solving Maths Problems, or on Twitter at Maths Math, and enjoy math and sledding.